This question is with regards to Math 1 to 2, Unit 6, Assignment 6 on the normal distribution. Question number 20. It says the weights of the melons produced by Jacob, the farmer, are normally distributed with a mu kilograms and standard deviation of 3.55 kilograms. If 2.68% of the weights measure less than 8.5 kilograms, find the value of mu. So this is a situation whereby mu is the unknown. So we can use unit 6 as a starting point to approach such a question. On page 14 in unit 6 is a section that deals with calculating the mean mu for a normal distribution, provided that you have some information given. It says situations will arise where the values of the random variable x, the probability and the standard deviation will be provided to you, and you will be required to determine the mean value, the population mean. For example, 5.5, where x approximates a normal distribution mu, and variance 25, and probability of x, that random variable less than 30.7 is equal to 0.9909. So you have to find the value of mu. So for starters, in this solution, it says, when you've got such a situation, pretend you know the value of mu and you are trying to evaluate p. So you would do what you would obviously have done if you knew what mu was, if you knew what x was, and if you knew what sigma is, you would basically standardize. So the first appropriate thing to do would be to standardize, and that's where it is on right here. X minus mu over sigma. Sigma will be the square root of the variance. The variance is 25. So here the standardization has taken place. 30.7 minus mu over 5. Now, the next step now would be to sketch the normal curve and the standard normal curve. The normal curve would consist of the appropriate shaded region and the bell-shaped curve. The shaded region now would depend on how the question is phrased. This question says that the probability of x less than 30.7. So we have to shade a region starting from 30.7 towards the left. Now we need to know where to begin. If it's to begin on the right side of 0, or if it's to begin on the left side of 0, meaning if it's to shade a region that is smaller than 0.5, or shade a region that is greater than 0.5 towards the left because of left side. Then that is where now we have to look to the probability value that is provided. We are given 0.9909, which is greater than 0.5. That's a phi of. In terms of the language that we are using here, it's a phi of. Phi of is a probability value, which is greater than 0.5. So in order to shift towards the left, a region which is greater than 0.5, we have to start on the right side of mu. So 30.7 must be greater than mu, because we're going to get a positive value for C. And because Z will be on the right side of 0, and a positive value of Z, meaning 30.7, will be greater than mu. Now let us compare this now to question number 20. When you look at question number 20, it says the probability value that we have to shade is 2.68%. That is 0.0268. That's a value which is less than 0.5. Now, in what direction? Towards the left or towards the right? We have to look at the next keyword, which is less than. Less than 8.5. We have to shade towards the left. A region which is below 0.5. So this looks like a left tail. Let's do the translation to make this a little bit clearer. The translation of this worded phrase to symbolic form. So here we are translating the word weights to the letter X. So X meaning the weights approximate a normal distribution with a mu, which we have to find a variance of 3.55 squared. Now, it says the probability that the weights are less than 8.5, here it is, weights are less than 8.5 is equal to 2.68%. 2.68%, that's 2.68 divided by 100, that's 0.0268. Towards the left, that's a left tail. So let's look at the curve, the appropriate curve for such a scenario. In unit 6, we can go to page 7 to get the curves. This is not the curve that we are looking for number 20. Actually, this curve is, for example, 5.5. A phi, meaning greater than 0.5 towards the left. This is not the curve neither. That's a tail towards the right. That's a greater than towards the right. And it's less than 0.5, so it's not a phi, it's a tail. That's a phi towards the right because it's greater than 0.5. And now, to be towards the right and greater than 0.5, you must start on the left side of mu. So therefore, your z now has to be negative. Now remember, the table that we are going to use only gives you positive value of z. And here it is. Here's the legend to tell you that all these is inside this curve are positive. All the probability values inside this curve are greater than 0.5. That's how this table is structured. Other tables are calibrated differently. Some tables give the tail, right tail, some give the left tail. Sometimes some even give the in between or midway between one side of the table. As you can see, all these values, probability values, are greater than 0.5. So this region is a probability value greater than 0.5, 0.94520 exactly. And if you go back into the table with 0.94520, you will get 1.6. But then now you now have to attach a negative sign. So towards the z. So once you go into the table, we'll be talking about that in a while, and you get your z. That's the purpose for that's the advantage of having the curve. And then you'll be aware or not if you have to put a negative sign to the z or not. Here now, we put a left tail. Towards the left, a probability value less than 0.5, 0.0268. So this is the appropriate curve for question number 20. And when you do your 1 minus, because this probability value is not in the curve, the 0.0268 is not in the table, sorry, is the 1 minus 0.0268. This region there, the phi of, that is in the table. So you do your 1 minus, you go into the table, you get your z, and then you go to attach a negative sign to it. Because you have to be aware that's a negative z in your scenario. Okay? So let's move on now to the example 5.5. So you complete your normal curve with mu, the letter mu in the middle, and your x is on 30.7. So that 8.5 will be on the left side of mu for number 20. Okay, that 8.5 will be on the left side of mu. But here our x or 40.7 is on the right side of mu. And we have a positive z. Once you go into the table, and we are going to show how we got the 2.36 using 0.9909 straight from the table because that's a field. So here is 0.9909, here it is. And the z is 2.36. 6 up there. Okay, 2.36. 2.36. And by the way, there is a little subtable below that facilitates that obtaining of z using p. It gives you the appropriate z or the corresponding z for the p. If you have a 0.75, you get a 0.674. If you have a z of a p of 0.975, you get a z of 1.96. Okay. So just remember, if you have a probability value which is less than 0.5, you have to do a 1 minus, go into the table, and you will know if it's to attach a negative sign to the z or not, depending on the tail. If you have a left tail, you have to attach a negative sign to the z. You will know if you have a left tail if your sign is pointing towards the left and your probability value is less than 0.5. Okay, because you can be pointing to the left and the probability value is greater than 0.5. That's not a tail, that's a fear. And that is the example that we have in example 5.5. Now, once you obtain your z, then it's history from there. You just plug in your z back into the half complete formula. Now you'll only have one unknown, and you'll just apply some simple algebra to solve for it. Let's take a quick look at example 5.6. Without even reading the entire sentence, let's look for the key terms. More than, that means we have to point towards the right. A probability value less than 0.5, that's a tail, that's a right tail. More than and less than 0.5, that's a right tail. There it is. We must do a 1 minus to go into the table to get the z. Okay. And then no, you don't have to attach a negative sign. So in summary, basically what you do, you standardize, ensure that you transfer, you can translate the random variable, define what it is. Pretend you're calculating z, you get an incomplete calculation of z. You'll have two unknowns, z and mu. Now you sketch your curve for it to know where your z will be. Okay, what kind of tail? You shade area which is less than 0.5 or greater than 0.5 towards the right or towards the left, depending on what was said. So the translation to symbolic form will give you a good indication if it's to point to the left or point to the right. More than is to the right, less than is towards the left. And then your mu is 0, that's your standard normal curve. You go into the table. Here we must do a 1 minus to go into the table because you cannot get 2.5%. So here the 1 minus was done, 0.975. That will give us a z of 1.96. It appears that you can use the subtable to find that 1.96. Here it is, 0.975 is 1.96. Substitute 1.96 back into the formula for z. Now you have only one unknown and just algebra from there. You will know that you logically think of your answer. This answer, mu is supposed to be less than 68, and scrutinize to see if it's making sense. So that's what you do for a question like this. All you need to do now is to continue by sketching the curve, complete the curve, do your 1 minus, get your z, attach a negative sign towards it, and then solve for mu. Your mu should be less than 8.5. You're supposed to get an answer less than 8.5.